So yeah, as I mentioned, my name's Gary. I'm here today to basically talk about all things vRA and Terraform. So vRA, or vRealize Automation, cloud version, basically allows you to provide multi-cloud infrastructure and application delivery to your end users. So it means you can deploy machines across all your different public, private cloud providers, ensure that teams can collaborate together, continuous delivery and release automation as well. So vRA is available, vRA consists of sort of three main services these days. First being Cloud Assembly, second being Service Broker, and the third being CodeStream. vRA is available both on-prem, called vRA 8, or the SaaS version called vRA Cloud. And the best part is it's super easy to get started. All you need is your credit card. It's really cheap to learn. The list price is something like 3 cents, US cents per hour. It's available globally. And if you're already familiar with vRA 8, if your organization already runs it, the cloud version is the exact same code base, and it's actually updated more frequently as well. So nice and easy to get started. So what is infrastructure as code? Something that I think a lot of people are talking about in the last year or two, especially. So it basically allows us to manage and provision our infrastructure through machine readable config files. And of course, we can store those config files in a version control system, which allows us to sort of speed up deployment times, reduce the risks with consistent builds. And of course, it's repeatable, so we can reuse the same code across all of our different environments. So there's two approaches, I guess, to automation in general. The first being imperative, the second being declarative language. So imperative language is where you define the steps to achieve something. So this could be PowerCLI, JavaScript or vRO, Python, all those sort of languages. The other side of things is declarative language, which is where you specify what you want your end result to be, not the steps on how to get there. So examples of this are, of course, Terraform, Ansible, Puppet, Chef, and PowerShell desired state configuration. So what is Terraform? It's basically an open source, free, simple executable file. You write your infrastructure as code in the HCL language, and there's over 200 providers to date, including all of the VMware products. So vSphere, NSX, vRealize Automation, I think there's a vCloud Director, there's lots of different providers out there. So VMware's really been good in jumping on board. I guess the next part is how do you get started? So with Terraform, we create Terraform configuration files, which is basically just a text file with a .tf file extension. We specify the provider we want to use. So this could be vSphere, could be NSX, it could be vRA. And we retrieve data sources from the provider. So this is where we want to retrieve some information out of vSphere or vRA or NSX, which is a data source. And then we create resources. So if we want to create a virtual machine in vSphere, that would be a resource. And then, of course, we can run any post-provisioning tasks using local exec or remote exec provisioners. So once we create our configuration file, we then initialize our folder and run the plan. And what the plan does is it checks that all of your local configuration files look correct. There's no syntax errors, and it will check what you're planning to do against your current state file to see what it knows about your current environment. So Terraform takes your configuration file, your state file, calculates the plan. You can then review the plan. The plan will tell you it will add one resource if you're creating a virtual machine, for example, and you can check that that's correct. And then you can run the apply command, which is where it will create, update, or delete the resource as required. So what does this look like? Let's jump into VS Code here. So we'll start off here. We've got our vsphere.tf file. And the first thing we do is reference our provider. So we're going to be using the vSphere provider. And we're going to
see your screen, Gary. We can still see the slides.
Oh, sorry. Let me switch that over. Thank you for noticing. Give me a second. Just reshare. Excellent. How's that?
Yeah, see that now.
Perfect. Okay, so we can. Sorry, I'm just getting slightly distracted. I'm sure you used to be able to screen share your whole screen, not a specific application.
Oh, that's interesting. So, maybe it's not just VMware people, but that means it's our end. Yes, normally you can share your entire screen with Zoom.
Cool. I thought I was going crazy. You'll have to bear with me while I switch as we go through. That's a bit of a pain.
Gary, can you zoom in a little bit?
Yeah, of course.
Thank you.
I
think you can do Command plus on a Mac.
So with the multi-monitors, it might be a bit. Does anyone know a way to do it in code? There we go. Is that a bit better?
Command and plus, but I could be wrong.
Is that a bit better?
Yeah, that's perfect. Thank you.
Excellent. So yeah, we basically connect to our vCenter server here with our username and password. That sets up our provider. And then we've got our data resources. So this is where we're retrieving information from vCenter. So here we're going to define a data resource called vSphere Data Center, and we're going to give it a name of DC. And we're going to find that object by searching the name vCenter Data Center. We do the same thing for finding our resource pool. We're going to call that pool, and it's going to look up the name vSAN cluster / resources. So that will specify the cluster that we're going to deploy to. And the data center ID will be the data source of our data center that we defined here, .dc, and it will use the ID that it's collected from that data source. Same thing for the data store that we want to provision to. We give it the name, and it will use the data center ID to find the actual object. Again, the same thing for the network. We give it the name of the port group that we're going to deploy the machine to. It uses the data center ID and finds the correct network. And of course, the same thing for the template that we're deploying from. So we're deploying from our CentOS 8 template. So once we've got all of our data sources, we then want to create our machine. So we create a resource of type vSphere virtual machine, and it's going to be called demo. And we're going to give it a name of vmug1, 2 CPUs, 4 gig memory, and we're going to specify the data store resource pool based on the information that it's retrieved from the data sources earlier. So we'll put it on our data store with the ID field, the cluster with the ID field, and it will get the guest ID and the SCSI type from the template that we provided. So it will make sure it's the same. We then specify the network interfaces on the VM. And again, it uses that data type to grab our port group and the ID. And we predefine what the disk layout is going to be. So here we're going to specify a single VMDK with 30 gig. And we're going to clone from that template. And we're going to customize the machine and specify the host name, the domain, the IP address, subnet mask, DNS servers, and the default gateway. So that will deploy our machine for us, run a custom spec, and specify by and set all of that information for us. And then at the end, we're going to run a remote provisioner, and this will SSH into the machine, and it will run a script, which we've got here called scripts example script. And it's just going to echo a few some text for us. But as you can see, that will actually SSH into the machine that we create to do that. So if we want to run this, jump into the right folder, and we're going to run Terraform plan. And we can see that it's going to, looks like I didn't clean up previously. So let me just quickly destroy that. Cool. So if we run our Terraform plan, we can see that it's going to add one new resource. That resource is going to be, we scroll up, our virtual machine, and it's going to specify all of the properties that we gave it. And there'll be some properties that we'll know after the build's finished, like the MAC address, for example. So we can run the apply on that, and that will go and create the machine for us. And I'm going to really quickly switch over to vSphere. Let me know if you can see vCenter.
Yeah, all good.
Yep.
Excellent. So we can see our vMag1 machine is currently being built. My lab's a little slow, so it will take a minute or two. But once that minute or two is passed, we'll see that it's on the right network, it's got the right IP address, it's got the right host name, and in the Terraform output, we'll see the hello world script that we gave it as well. So we can see it's using the credentials that we gave it in Terraform to run all of these tasks. It's going to power it on. So I am just curious, have many people here actually used Terraform in anger?
Regrettably so.
Yeah, I have.
Excellent.
Hands on lab here.
I gotta admit, my current client, we're being forced as the only way that we can consume a public cloud provider through Terraform. So it's proving interesting.
Only thing I would say with that is be careful of your state files. There has been a few instances where I have genuinely taken out a production environment because the state files got, should we say, muddled between users.
Yeah.
It wasn't the best thing because it took out the firewalls. So I was like, whoops.
Yeah, definitely need a proper remote backend for collaborative use.
Yeah, I think that's the point. Loads of people use Terraform quite heavily, sort of by themselves, and it's awesome when you do that. And then when you've got when you start scaling it to several people, you need something to manage state really carefully.
Yeah,
that is for sure.
Excellent. So we can see here the machine's been built. It's got the notes that we gave it. We can give it a second. We should have an IP address pop up. It was there before. There it is, 240. So that's the one and the host name that we specified in our configuration file. So if I stop the sharing and switch back again, sorry, this is going to get very old very quickly. Cool. So you should now be able to see VS Code has created the machine. Excellent. Is that sharing okay?
Yeah, we see the VS Code.
Perfect. So machine created. Let's switch back to presentation. Okay, so that's just a pretty simple example using the vSphere provider. Next up, we're going to have a look at the vRA provider. So there's sort of two main things you can do with the vRA provider. You can set up all of your infrastructure. So things like creating projects, all of your cloud accounts, your blueprints, your image profiles, size profiles, network profiles, all those sort of things. The other thing you can do is you can consume your infrastructure. So you can deploy VMs based off your blueprints to your public and private clouds. You can deploy your Kubernetes clusters and namespaces. You can run your code stream, CI/CD pipelines. You can request orchestrator workflows, all of those sort of things. So two main use cases, one for your sort of vRA admins and one for your vRA users, I guess. So I'll have a quick look at the vRA provider. Let me switch back. Excellent, that should be working. So if we jump into our vRA provider, and we'll create a project. So if we look at our code, so we've just got project.tf. So again, we specify the provider we're going to use and any properties that we need. So for this, we're using a token to connect to vRA, and that is defined in our TF vars or variables file, along with a few other properties. So we need to grab just one data resource, and that's the vRA zone, and it's going to look that up based on the zone name that we specify in our variables, which is this one here. And that's just going to connect to the same vCenter environment. We then create a resource of a project, and we're going to give it the name and description, again, that we specified in the variables file. We're going to assign it to the zones so that you can straight away consume from the vSphere environment. And we're going to set some limits on, you can only deploy 5 instances, can only have 16 CPUs, 16 gig memory, and a terabyte of storage, for example. And we can specify who the administrators, the users, and the groups in these fields, and specify our machine naming template. So if you want all of the VMs in this project to be built with a specific name, you can specify that here. So we'll quickly run the plan on that. And it's going to add one resource. So we'll quickly apply that while I switch back to the browser. There we go. And if we jump over to vRA, have a look at our projects, we've now got our new project created. And it's assigned the 2 roles that we wanted. And we can see that we can provision to the vSphere environment with those 5 instances, 16 gig memory and 16 CPU limit, again with the terabyte of storage. And our machine naming template is specified as well. So that's nice and easy. We'll switch back to this one now. So creating the project is sort of the vRA admin's role. For the vRA users role, the thing that they're going to want to do most often is request a deployment. So we'll just take a quick look at what that looks like. So again, they'll need to specify their token to connect to vRA, and they'll need to know the machine blueprint name that they're deploying. So in vRA, I've got a blueprint called GCP machine. It's within the management project, and we want to create a deployment called vmug London deployment. So nice and simple. We'll quickly go through the Terraform file. So again, specify the provider and the properties. The data source that we need to grab out are the project. So we give it the name, it will find the object. Again, the blueprint that we're deploying from, we give it the name, it will find the object.
I think you might need to switch back to your.
Sorry.
Sorry.
Cheers. How's that?
Yep.
Perfect. So yeah, config, data sources, and then we're going to create a deployment. The ID of that we grab from the data source. The deployment name we've specified as a variable. The project, again, we've got the data source here. And there's a couple of inputs, for this blueprint. So we need to specify the flavor, so the size, what image we're deploying, and what tier we're deploying it to, whether it be app, web, or DB. Then at the end of that, we're going to output all of the properties. So nice and simple again, we just run the plan. We can see that it's going to add one resource, and it's going to output the properties by name. So we'll just run the apply on that. And that will take a couple of minutes, but I'll switch over to vRA. And we can see here vMug London deployment has been kicked off. And what this blueprint is it will actually create a machine within GCP for us. So it's done all the approvals because we don't have any. It's creating the network within GCP. So from here on, it's only as quick as GCP allows it to be, basically. And we create the machine. So at the end of this, you'll get your machine. You'll have the IP address, which you'll see in the output that we provided. And we can have a look in GCP as well. We can now see our machine being built. So I think what the real value I believe in this is that you're basically obscuring the complexity of your public cloud to your developers. So all they need to do is, whether it be through vRA UI or Terraform or whatever, to deploy a machine, they only need to know a handful of values. So what OS, what size, and what tier, for example. It could be what region, it could be whatever properties you want to give your developers. And then in the background, vRA does all the mapping for you. So it will decide, okay, does this machine live in vSphere? Does it live in GCP? What tags do I mandatory need to apply to the machine? All of those sort of things that usually get missed. You're just automating those steps for your users. So we can see that machine is created. Go back to our deployment, it's finished. So I'll switch back to code.
Just out of interest, Gary, do you get the share desktop option now?
Oh, let me give that a go. No.
Okay, all right, fine.
It might not take effect to the next meeting, Simon.
Yeah, okay, no worries.
Yep, so because we specified an output, we can see what it's actually created, and we can see what networking details it's given it, all of the sizing. There's the IP address that it's grabbed from our pool. And yeah, that's created our machine for us. So let's flick back to PowerPoint.
Presumably that deployment we've done there is fairly transparent between, I don't know, GCP, AWS, and Azure.
100%. Yeah, I've just used GCP just because that's what I'm using in the current project. But yeah, exactly the same for AWS, Azure, even vSphere. But yeah, so let me switch. We'll do one more thing quickly. Actually, let's go this one. Excellent. Are you able to see PowerPoint?
Yeah.
Excellent. So that's all well and good. We can consume vRA through the UI, we can consume it through the API, and we can now consume it through Terraform code. But there's another functionality on top of that, which vRA has added, which is about adding your existing Terraform code. So you might have Terraform code that creates an F5 load balancer along with ServiceNow integration or your Datadog integration or all of those providers that Terraform supports, but vRA doesn't. So in vRA, we can actually provide those configurations for users to consume. So if we have a look at my this diagram here, thieved from VMware. So basically in our blueprint designer now, there's a new option for Terraform configurations, and we can point the blueprint to a Git repository with those configurations, and we can present them in the catalog to be consumed as they would anything else. So one of the big sort of pain points of vRA is that it doesn't support a lot of things. For example, F5 load balancers or monitoring tools like Datadog or any of those things. Whereas with this is you can provide the capability through vRA, but in the background, it's actually running Terraform code to provision those resources. So the benefit of that is one of the big pain points we mentioned earlier was shared state. So vRA becomes the shared state provider. And you on that state file, you can run day 2 actions, you can import workloads, all those sort of things. And as I mentioned, those Terraform templates will now be available within the Service Broker template or ServiceNow if you use that integration. So like we sort of said, all the benefits of shared state, the benefits of vRA, so we can actually enforce provisioning policies. So we can set lease times, approval checks, costs, version checks, all of those things that vRA does really well that maybe Terraform doesn't. So we can sort of get the best of both products, I guess is the way of looking at it. And of course, from your user's point of view, if they're already using the self-service catalog, well, Terraform resources just become another consumable item, basically. And of course, we can do hybrid blueprints. So you could specify, say that there's a new cloud provider and VMware hasn't added support for it yet. We could specify that in the template as this ABC Terraform, for example. But then we want to also hook it up to our existing Puppet integration, which vRA does have. So we can put them both on the same blueprint. And of course, we can run extensibility on those things as well. So our ABX actions and our vRA workflows as well, which I think where's sort of the main value of vRA is around the extensibility options. So what does that look like if we stop and switch back to code? Excellent. Over here, so in our request anything deployment, let's have a look. So we've got our main file, which again just specifies that this time we're going to be using the Google provider. So we're not using vRA at all. We're going straight to Google to get this information. We're going to provide it some credentials. So if you've ever used GCP, you know that service accounts output a JSON file, and that's fine there. I won't open that up, but it's got the credentials in it. And the project that we're going to specify, that we're going to link it to. So we'll have a look at our file. So this one's going to be a bit more complex. So we're going to create a pool of VMs, an auto-scaling pool of VMs with a firewall and a public IP address. And we're going to create a web page that's serviced from those VMs. So for that, we need a couple of different resources. We need a public IP address. We need to create a firewall that allows internet access over TCP to the port that we're specifying, which we've got specified as port 80. Then we're going to create a forwarding rule. So we're going to forward everything to our compute pool that's coming in from the IP address. We're going to create that target pool, and we're going to create a health check that checks sort of those values for how frequently it needs to check, and it's going to check that our port 80 is up. Then we create our instance group manager, which has our target pool specified, and we create our autoscaler that specifies I'm going to need a minimum of 2 replicas, a maximum of 8, and a cooldown period of 60, so that we're not going to spin up a heap of machines up and down all the time. And we're going to do that when the CPU utilization of a machine gets to 50%, then we're going to increase or decrease the number of VMs as required. The VMs that we're going to deploy are F1 micro machines based on Ubuntu 18. We're going to run that in our home lab network with that subnet. And we're going to create the website, which is basically just a basic HTML file being run on a HTTP server on the VM. So we can switch to that folder. Run our plan. All looks good. 8 resources to add. Run our apply. And that's going to go off and create the machines for us. So that's how your developers would probably do it today. And they would need to have a credentials file and do all of that to talk to Google directly. Whereas an easier way would be to provide this information within vRA. So if we flick over to vRA, we can create a new Terraform blueprint, and we're going to call it GCP mug. Cool. So what we can do here is we can actually specify that we specify the Git repo that exact. Did I switch the screen? Yeah, sorry. There we go. So basically we go new Terraform template, and we're going to call this a mug. Specify our Git repo, specify the commit and the directory. And what this will do is grab our Terraform code in that Git directory. We can specify what version of Terraform we want to run, and it can find, okay, we're using the Google provider. We're going to deploy it to this environment, and we can create that. And we can see one resource here. And just like everything else, we can present it to our users and they can consume that. I won't go through all that because it does all take quite a bit of time. But if we switch back to code, we can see our 8 resources were created. Just go through those. So the address, the firewall, the instance templates, the health check, forwarding rules, all of that's been created, and it's outputted our public IP address. It won't be instantly available, but if we give that a minute or two, or 5, our web server will be available on that public IP address. And that will probably take a few minutes. So I'll just flick through the rest of the slides. So if you are interested in any of this, I've got a blog with all of the steps. The vRA's Automation Cloud site has some good information too. Terraform can be downloaded from here, and the vRA provider actually gives you a good list of examples with the link there if you're interested. Well, that's pretty much it. The creation does take a couple of minutes, so we can awkwardly wait for that, or if there's any question, oh, there we go. Perfect, good timing. So that's our public IP address fronted the 2 or 3 machines. There we go, base instance. It's actually built 5 machines. Yeah, so there we go. Any questions?
Nice demos, Gary. Are you using this in your current projects? Is it something that you're using in anger, or?
Yeah. Basically, it's a GCP project or vRA and GCP project, and the only way to consume GCP is via Terraform code. So it's been a very quick get up to speed on it.
What, you didn't feel like writing dynamic types and custom resources to consume cloud native services?
Yeah. It's been good fun.
Yeah. And is that using the service, the Terraform provider service within vRA?
At the moment, no, because we can do everything using native vRA. So we're not using the vRA service provider yet, but there is a use case that we've talked about that might go down that path.
Yeah. It's a good demo. I like it.
Cheers.
Yeah, always good to see demos. And I did verify that it is actually a real demo because I can get your IP address. So obviously it wasn't.
Yeah, cool.
Should we test his auto scaling if everyone hits it and we refresh multiple times?
You mean should we test his credit card limit?
Oh, I'm gonna regret that.
No, that was really good, Gary. So thanks for that.
Awesome.
It's cool. So I mean, what other stuff have people done with Terraform? I mean, I don't get to do much more than drive PowerPoint these days, it seems. But I have done a bit of experimentation with Terraform on Azure. Right? I mean, I think it's been a fairly steep learning curve to get going, but it does, it does seem quite powerful.
Yeah, I think the entry level to it is actually not too hard. There's a lot of examples out there. It's when you start creating things sort of dynamically and looping through variables and you start building different layers of complexity on it, you can get to some really, really complex solutions with the Terraform providers, which, I mean, I was looking before. So previously, Terraform was one of my responsibilities within the team that I'm in, and it's not now, so I don't do too much of it anymore. But we were looking at building our field demo environments, so we rebuild every night. We were looking at rebuilding them in vRA, so using the vRA provider to rebuild whole vRA demo environments each night, which at the moment we run Python scripts through pipelines, which can and does fail on a semi-regular basis, whereas the Terraform provider, like, once you've got it sorted, it's very unlikely to fail. It's pretty robust.
I'm going to put a terrible plug in there, but I'm getting back into Terraform again. And I've kind of taken a bit of inspiration from kind of the days of Autolab and the VTardist, as Simon will probably remember very well. And taking things like from Alan Renouf and kind of William Lamb stuff. So essentially what I'm trying to do with that bit there is I'm trying to get more used to the whole kind of, even that blog there that you're reading, if you click on the link, is built from a pipeline. And the aim of what I'm going to try and do with this project is, if you have a vSphere environment setup or a very basic, cloud setup, is you'll be able to build a lab with hopefully a few variables set in a file and away it goes. Or that's where I'm trying to aim to it. So, I think many of us are fed up of rebuilding our home lab when a new version comes out, be it Windows or whatever. You've got to dump the ISOs in a place, it builds everything with Packer and then calls Terraform and starts building that all the way up to the Active Directory domain as well. It's just, remote provisioners can sometimes not work the way you want with Terraform.
That thing about Autolab, Sam, you did an excellent blog on doing it in Ravello, which I managed to also spin one up, but unfortunately got taken over by Oracle, so that sort of dead-ended.
Well, that's again, there's a bit of inspiration for this really as well, is that eventually I want it to be kind of somewhat platform agnostic, so you can just set a variable in the file and go, well, do you want to build it in, you've got a vSphere environment, build it there. Do you have a GCP environment, build it there? Do you have a AWS environment or Azure? And that's how I'm going to slowly build this project up, is you say that my domain is called blah, this is my IP address range, and then you basically say go, and then it will go make sure that it's got the files it needs, like the ISOs or what AMIs you want to use, and it will just kind of do it all. It's just going to take me a little bit of time to do it, unless anyone wants to give me a help with it. I
always think with those things, the iterations are what take the time. I mean, I remember when I did all this stuff in PowerShell, right? By the time, it wasn't running on the most powerful hardware to start with, but by the time you start to get it to deploy everything to run through the configurations, because a lot of the stuff has to be done sequentially, right? You've got to have DNS before you can have this, before you can have that. And it invariably fails at like 99%. You know why it failed, so you fix it, but it then takes 2 hours to go back to the beginning of the run again, which is a little bit frustrating. Which is why I think those things do take time, but they're really cool when they work.
That's why the code in there is not moved for about a week, because it's just not quite played the way I want it to. But it's going to get there. It's just interesting way of doing it. I've tested it again. The driver is it Windows 2022 is so say out or whatever they're going to call it, and I thought, well, the lab needs rebuilding, and I can't be bothered to build a domain. I can't be bothered to do this. Why can't I automate it?
Or dare say you've run out of a license for vCenter.
Well, there could be options like that. Accidentally, you're running out of licenses. Oh, well, just blow it away and you can build it again. And as you said, within 2 hours, I can have everything back up and running. And it's useful for me sometimes to test iterations. So if I've been tweaking something and then maybe the company I'm working for, we might release features, it's good to test it against a completely well-known vanilla environment versus one I've tinkered with.
If you don't mind me asking, Gareth, are you doing that as a public, like GitHub repo?
Yeah, there's a GitHub repo there. So
nice.
And that's why I was looking at some of your stuff and like how you're running scripts to how I'm doing them.
Yeah.
So I'm personally pushing a lot of the scripts to the machine, so I know they're running on the machine and there's no firewalls or anything in the way. And it's just different ways of doing things. And that's why, if anyone wants to help, I'm all ears, because I think it's one of those community projects, a bit like Williams Lamb scripts and whatnot. I want it to be there to help everyone. Even people just starting with Terraform or Packer, they've got something they can grab and it will do the most basic jobs and kind of start working.
Yeah, it's nice to have a framework you can tweak.
Yeah, well, that's the biggest thing, is trying to make it as a framework. And that's what's taking a lot of the scripting in there and trying to get it to pull in variables. And the eventual aim is to then have an XML file that is probably going to use PowerShell as a wrapper that will then go off and, basically pull in that file and go, okay, I'm going to build Gary's lab today, or I'm going to build, Joe's lab or whatever. It will then go off and do it. It sounds like the biggest problem is putting in so much sense checking, like even something simple as I've had to write code within Terraform to go wait for a service to poll before it continues. Otherwise, as Simon invariably says, it fails at like 98% and you have to start all over again. So it's adding bits in there saying, okay, I've even made I actually wrote the script for you might see Michael Cade's Veeam project that he did. And that was one part of enhancing it. It was waiting for a service to become available before it would continue the build, so it could be fully automated. It's just all those little bits that just take time.
Yeah. Do you come across? I mean, one of the, I guess when I look at doing this elsewhere on some of the things I've been working on, I always think it's better to work with, or at least in my experience, the kind of native constructs that you get out of, particularly all the hyperscalers, right? You know, AWS, GCP, so they give you a really good abstraction on top of everything they run underneath. So to me, sometimes Terraform is obviously an abstraction that sits in front of that. It gives you a really good bit of portability, but I guess the trade-off sometimes is that, presuming if AWS release a new feature, you're presumably then dependent on some kind of provider in Terraform to be written for that. I mean, what's people's experience of the kind of how long that takes to get some of those providers, or even how easy it is to do it yourself?
I've seen it in reverse. Sorry, Sam. I've seen stuff happen in Terraform before the Amazon API a few times.
Yeah. Well, I was going to say, for Google specifically, they've got a commitment that any GA feature will be supported in Terraform at release date.
Yeah. You'll find it the other way around. You know, when we were doing, what's the stupid other file services on AWS? We found it was available in Terraform before it was in their own API and CloudFormation. It was stupid.
Yeah, and so you can automate the build as well. So I know with the vRA SDK, which is what the Terraform provider is built on, we take the Swagger from the latest release. So we take the API Swagger file definition and we use that to build the vRA Go module, the SDK Go module, which then trickles down to the Terraform provider. So you can if you've got a well-defined Swagger, and I'm not saying that our Swaggers are that well-defined, but if you have got a well-defined Swagger, you can actually automate the build of your Terraform provider almost completely. So I think you'll see that, like as a module gets more and more more consumed, more people are using it, they're relying on it, then the build process starts to get automated and it catches up very quickly to services. But having tried to write Terraform module myself, there are smarter people than me doing it by a long way.
Cool. I think there were some links that you had maybe in your deck, Gary. I mean, is that something you can maybe paste in the chat so people can do some?
Yeah, of course.
Some further reading. I think those would be. I mean, I'd certainly personally be quite interested to go and have a look at some of that.
Yeah, I'm already looking at your stuff, Gary, and going, well, I might even add some of this stuff to the stuff that I'm doing, just to enhance it even more.
As I say, we didn't even touch Packer today, but at least in my lab, I've got sort of all the flavors of Windows, Linux, just auto patching, creating a template every month, as a few others in the community have.
So I guess just as a bit of a tangent, because I've not really played with Packer. I mean, how does that work? Does Packer provide you presumably do some kind of inline streaming of patches into those images, into like the WIM images?
So you can basically just build it off a known source. So for Windows, for example, I've got the ISO on one of my vSphere data stores, build the image, and then it runs. There's like a Windows Update provisioner. So you can specify I want to run all patches that match this query. So not a preview patch, for example. And it will, as part of the Packer, just patch it completely up to date, turn it into a template, and then bring it back so that you can consume it.
Okay, so the output's a templated VM.
Yeah. And I used to use this a lot for gosh, it's gonna sound old school, but keeping consistency across things like remote desktop images. So within reason, I would use an ISO on my vSphere. I'd use a certain version of AMI on Amazon, and then same on Azure. But at least then I knew those were built to a very specific set of criteria and had the consistent app across them all. So if a user hit it, the only difference would be what platform it's running on, with a slight variance in the underlying ISO potentially. Otherwise, it should be consistent across clouds. Well, that was the goal.
Yeah, that's one of the nice things about Packer is you can specify multiple targets as well. So you can build the same image to all 5 different vCenters or vCenter and AWS and GCP. You can do it all over the place and basically spray your build wherever you need it. And the idea is that obviously you're going to get the same image at the end of it. I think you can also do it based off of an existing template as well. So you can actually deploy and update a template using Packer, as far as I know. So like if you want to just streamline your patches into the existing image, then you can do that. But typically, if you've got a Packer template that's already building your template up to the point where you've where it's good enough to be your template, then it doesn't take much to just rebuild it from scratch with Packer.
How do you get the? So I mean, if I think about the way, it's been a long time since I've had to do this, right? But you would get a vanilla OS image. I would usually run the offline WSUS utility that would then basically you select which patches you want, and it would squirt them and patch that machine up, and then shut it down and convert it to template. But I mean, how do you get Packer to inject those patches in? And do you have to run it interactively inside that machine, or does it need some kind of agent?
I don't know how the other guys are doing it, but I just use the auto attend XML and just put it in there.
Okay, so you kick it off. Fine. Okay. Yeah. Gotcha.
Yeah, you can do it like that. You can also run scripts like post deploy and at different stages. There are actually quite a few modules. The Windows Update modules, I think Gary mentioned he uses that, which obviously allows you to run Windows updates against it and install the packages you select or everything. It's quite useful. I use it in our labs to provide the various different flavors of because we have 5 or 6 vCenters in our field demo labs. Each vCenter needs to have the same image flavors around, and so we use that to build and spray that. And also one of the things that we're doing now is through pipeline automation, we're actually building the image, adding it to vRA, and then deploying that image and then running salt stack config against it to get a security checkbox that it's not got any of the vulnerabilities and not got any services running that shouldn't be and all that sort of stuff. So it's taking that whole like DevSecOps config kind of idea and saying we're actually going to automate a security scan before it then gets released as a template. So you can make it really complicated if you like.
Ooh. Very good. Got any other questions for Gary before we do the closing? No, if not, okay. Thanks, Gary, for that. That was really cool.